All right, guys, are there any questions on the homework assignment so far? Any questions on the one assignment we've had so far? All right, guys, so if you'll put your Chromebooks away and headphones out, we're going to go on and get started with the lesson today. And what we're doing is we're finishing up the work or the lesson note sheets from yesterday. We finished up solving this one here, or finishing multiplication of this problem here yesterday, and we'll do another one like it here today. So this is the one we're going to be starting off with today. And as we saw yesterday, when we multiply these two rational expressions together, it's going to be really helpful if finishing it from yesterday, and that looks like the day before. 7.31. Yes. Huh?
7.1. That's just one.
Yep, so that's it. Well, it's not the right note sheet, but it means we're out. Now, looking at the 4 here, we know that the 5x will not factor at all because it's just one term and there's nothing we can do with it. Now, if we look at the others, the first one we can work with is the 5x minus 5x squared. Now, since there's only two terms, the first thing we can look for, and most likely all that there's going to be, is a greatest common factor between them. And if we look at these two terms, what would the greatest common factor be between 5x and 5x squared? 5x. And we're going to factor it out. And we had something like this similar yesterday. Now, if we look at this here, the 5x squared is in the second part, and it's also what? Negative, yes? And if we factor the 5x out, we'll be left with a negative x. Now, in all the other factors, the x is going to not be negative, it's actually going to be positive. So maybe instead of just factoring out the 5x, we can actually factor out a negative 5x. And by doing that, it's going to change that x squared from being negative to being positive. And when we factor out, we'll just get a positive x. Now, when we factor the negative 5x out, well, our first one is 5x. Because the 5x would factor out completely, and it would normally leave us with 1. But this time we factored out a negative 5x, so it's not going to leave us with just 1, but negative 1. And we'll switch it so that the x is in front here in a minute, but we'll factor out the negative first. Now for the second part, we will factor out the negative, which makes it positive. The 5 will factor out completely, and when we factor an x out of x squared, we're left with x. If we wanted to, we could have switched it to x minus 1 here, but I didn't want us to factor out the 5x and the negative and flip it all in one move. So we'll switch it here in a minute. There's a pencil in the top drawer. Or you can use that one. Yep. Now that leaves us with the other two to factor. So it's the note sheets from yesterday. We can factor either one of these first. It really doesn't matter which. Now, if we factor the x squared minus 4x plus 3 first, we need to find the sign. Since the third term is positive, the signs are the same, and they match the sign of the middle term, which would be negative and negative. Now the factors of x squared, x and x, and it works out the only factors of 3 are 1 and 3. Any questions on this here?
How many do we do drugs?
No. All right. So we finished factoring the x squared, guys. Factoring the x squared minus 3x, or minus 4x plus 3. Now we just need to finish factoring the other one, x squared minus 5x plus 6. Again, since the 6, the third term is positive, the signs are the same, and they match the sign of the middle term, which would be negative and negative.
Clinton, I have a question.
Yes.
What was your first ever job? Dude, you are so
Coaching tennis.
Wait, how old are you?
I am going to be 32 this year.
I thought he was like 26.
Now, looking back at this here, the factors of x squared would be x and x. Now, we do have a few more factors of 6, unlike 3. 6 and 2 and 3.
1, 3? Or 1 and 6?
1 and 6, or 2 and 3. It's going to be more helpful to use 2 and 3. And we can check this here to make sure that this is the correct setup. We do this here, x times negative 3 would be negative 3x. Negative 2 times x would be negative 2x. Negative 3x minus 2x would be our negative 5x. So this would be the correct setup here. And now that we do have all of these factored, we can multiply them together. And we multiply them together. On top, we would have the negative 5x out front times x minus 1 times x minus 2 times our x minus 3. And this is going to be all over our 5x times x minus 1 times our x minus 3. Any questions on this here? Now at this point here, we can simplify what's in common on top and bottom. So we can cross out the what? The x minus 1 and x minus 1, as well as the x minus 3 and x minus 3. Anything else?
You can mark up the 5x.
And the Now, at this point here, do we have anything left in the denominator, the bottom of the fraction? No. So we'd have negative, parentheses, x minus 2. And that would be it. Guys. Any questions on any of this here? All right, guys, let's look at the next one here. So we have 2x squared minus 10x over x squared minus 25 times x plus 3 over 2x squared. Well, we can go on and just rewrite 2x squared because there's nothing we can do with it. We can't factor it. And there's no greatest common factor with just one term. There's only, for 2x squared? We'll get there in 1 second. Because we can, but we'll get there in a minute. Because the 2x squared I wanted to look at first because, well, it's the only term, so we can't do anything with it. Can we do anything with the x plus 3? No. So we can go on and put both of those down because there's nothing we can do with those. Now, exactly, if we look at the 2x squared and 10x, they do have a greatest common factor of, and x. Because 2 is the greatest common factor between 2 and 10, and they do both have an x. Now, if we factor 2x out of 2x squared, we're left with x minus 5. Because for 2x squared, the 2 would factor out completely. And we would remove 1x from x squared, leaving us with x. And we'd factor a 2 out of 10. 10 divided by 2 would give us 5. And the x would factor out completely. So we finished factoring everything except for the x squared minus 25. Now the x squared minus 25 is a difference of perfect squares, which would factor to x plus 5 and x. So that would be all of the different parts factored. Now we just need to multiply them together. So the numerator, we can put the 2x out front, times x minus 5 times x plus 3. In the denominator, we're going to have 2x squared times x plus 5 times x minus 5. And at this point here, we can cancel out what's in common. Because the 2x on top would cancel out. Because the 2 and 2 would cancel out completely. But how many x's do we have on top? How many do we have on bottom? So it'll only cancel out one of the ones on bottom, x.
McClendon was telling us that the other day y'all were heading to Tulsa.
Yeah.
And like you were just like really zoned out, and she was like, "What's wrong with you?" And you were like, "I'm just thinking about math problems in algebra too."
Yep.
Like in the middle.
So looking at this here, we just need to finish up what's left, because what's left on top is, and on bottom is. Mm-hmm.
Oh my gosh, did you?
And that's it.
Got you there.
Any other questions on this here?
No, but that was hilarious.
Let's look at this one.
Let him do it, please, Mr. McClendon.
Okay.
Alright, get up there. Come on, Craig. Mr. Confident, go up there. Get up there. Get up there. Can you start it for me? Once we get that.
So when we look at this here, we want to factor these down. Now, when we see c to the third plus 8, hopefully this will be a sum of perfect cubes. If we take the cubed root of c, we would get, well, c cubed, we would just get c. The cubed root of 8 is 2. So that tells us that this is a sum of perfect cubes. So when we factor this here, we would have the set of parentheses with 3 spaces and the set of parentheses with 5. And our signs would be the same, opposite, always ended on a positive note. Same, opposite, always end on a positive note. Now for the terms that go in there, we'll start off with c since it came first. So we'd have c. This here would be c squared. C to the first, and then the last one would not have c, because it would really be c to the 0, which is just 1. Then we can plug in 2. So here we would have 2 2 to the first, and then this here would be 2 squared.
Okay, so you got it from there? This one's different than the others, so.
Now, before we finish the rest of the factors, I want to simplify down this quadratic part of the sum of perfect cubes. Because here we would have c plus 2. Here, our c squared would turn into c squared minus 2c plus 4. Now, there is something interesting with that. Does anybody see it?
They're all multiples of 2.
Because we do have c plus 2. What else do we have?
2c plus 4. Wow.
C squared minus 2c plus 4. Is that anywhere else in here?
It's on the bottom of the
So that means, well, I'm going to do that. But these two here already match. So do I really need to do anything with this other c squared minus 2c plus 4? Well, no. So that means I can go on and just write it down on both, because we're not going to have to do anything with it. It's already going to cancel out with the one on top. It also works out that the quadratic part of the sum or difference of perfect cubes, this here, will never factor. It doesn't have real solutions, which means this one here is not going to factor either. So that's kind of nice, so we don't have to do anything with it. Now what that leaves us with is these other two here. We have the c to the 5th minus 4c cubed, and c to the 6th minus 4c to the 5th plus 4c to the 4th. For this one here, because is there a greatest common factor of c to the 4th with all of those? Do they all have at least 4 c's in each one? So I can factor out c to the 4th as a greatest common factor. We can remove 4 of them from all 3 terms because they all have at least 4 c's in them. And if we remove 4 c's from c to the 6th, we're left with c to the 2nd minus 4 c, because if we had 5 and we remove 4, we're left with 1, plus 4, because it had 4 c's and we removed them all, so we're just left with 4. And well, after removing that greatest common factor, we're left with c squared minus 4c plus 4. Well, that's something we can actually factor. Well, also looking at the c to the 5th minus 4c cubed, is there a greatest common factor there? C to the 3rd, because both of them have at least 3 c's in there. And if we factor that out, c to the 5th becomes c squared minus 4. So with those other two, we really needed to factor out a greatest common factor of c, and it brought it down to something that we know how to factor. Let me start over here, c to the 4th. We'll have 2 sets of parentheses. And as we factor c squared minus 4c plus 4, since the 3rd term is positive, the signs are the same and they match the sign of the middle term, which would be negative and negative. Now the factors of c squared would be c and c. Now the factors of 4 that we have are 1 and 4 or 2 and 2. We would use 2 and 2. And that there would be the factors for this one here. Any questions on this here before we look at the last one to factor? Well, the last thing we need to factor is c squared minus 4. Well, c squared minus 4 is a difference of perfect squares. So it would be c 2 and c plus 2. Because our difference of perfect squares will almost be the exact same, just have a different sign in the middle. And we could have had it plus and minus or minus and plus. So I could have said c plus 2 times c minus 2, and that's perfectly fine. The order really doesn't matter. And lastly, we can multiply these all together. So we would have c to the 4th times c plus 2 times c minus 2 times c minus 2 times rc squared minus 2c plus 4. All over c cubed times c minus 2 times c plus 2 times rc squared minus 2c plus 4. Now this really leaves us to cancel out what's in common on top and bottom. Is in common on top and bottom, so we can cancel it out. And c plus 2. And c minus 2. So 3 of the c's will take out 3 of the ones on top, leaving us with just 1 c on top, since there were more of them on top than bottom. And that's it. Any questions on any of this here? Let's look at the next one here. So we have this one here and 2 more, and then we are actually done for today. So the first thing we need to do is to factor these here. Well, we do have x cubed minus 27. So this here is possibly a difference of perfect cubes. Yep. So we would be left with, because the cubed root of x cubed would be x, and the cubed root of 27 is 3. So this would be the difference of perfect cubes. So for our parentheses, we'd have one where we're going to put 3 terms and one we're going to put 5. And the sign for this here are going to be the same, opposite, always end on a positive note. So we'll have negative, plus, and plus. Now we can plug the first terms in first, so that would be our x. So here we would have x. Here we're going to have x squared. X to the first, and then our term without x. Then we can plug in our 3's. So here would be 3. Our middle one would be 3 to the first, and then the last one would be 3 squared. Any questions on this so far? What are we expecting the quadratic part of this to turn out to be? Well, most likely it's going to be our x squared plus 3x plus 9. Okay. All right, so let's factor the other two. So if we look at those other two, just like the ones we had previously, most likely they do have a greatest common factor. So for our x to the fifth minus 6x to the fourth plus 9x cubed, there's a greatest common factor of what? X to the third, and no.
I'm really thinking about getting on some because I cannot stay awake. Hey, steroids. I gotta run or something. I take steroids.
X squared, guys, minus 6x plus 9. Because if we factor the x cubed out, we're left with x squared minus 6x plus 9. Now in the denominator, we have x to the fourth minus 9x squared. Well, there is a greatest common factor of squared, which would leave us with x squared minus 9. Guys, thank you. Guys, let's focus up here. We can talk about that here in a minute. Now for the difference of perfect cubes, we do need to simplify the quadratic down a little bit because our x squared is going to be x squared plus our x times 3 is 3x plus 3 squared is our 9, which does match up to our x squared plus 3x plus 9 down here. So those do have match up and they are in common. Now we need to factor the x squared minus 6x plus 9. Since the 9 is positive, our signs are the same and they're to match the sign of the middle term. So we would have negative and negative. The factors of x squared are going to be x and x. And the factors of 9 that we want would be 3 and 3. And we're done with that part. We still need to factor the last space here. So we need to factor x squared minus 9. Now x squared minus 9 is a difference of perfect squares. X plus 3 and x minus 3. So the last thing we need to do is multiply these together and simplify. So we have our x to the third times x minus 3 times x minus 3 times x minus 3 times our x squared plus 3x plus 9. And this is all over our x squared times x plus 3 times x minus 3 times x squared plus 3x plus 9. Now the x squared plus 3x plus 9 is in common on top and bottom, so we can cancel those out. We can take away one of the x minus 3's on top with the one on bottom.
Can't you take away the x plus 3 and the x minus 3?
Not quite, because since they have to have the same sign in the middle.
You have 1x squared.
And I think that's where you were going, Caleb. We'd have 1x on top. We have x times x minus 3 times x minus 3 on top and x plus 3 on bottom. Now we don't have to write the parentheses on bottom since x plus 3 is the only thing left, but we can still write them if we wanted to.
So why can't we combine x minus 2 and x minus 3?
To this here? Yeah. Those are the same thing. Those are the exact same answers. It's just a different way to write it. Any other questions on this here? Guys? Caleb? Caleb? Thank you. Any other questions on this here? All right. This is the last type we want to look at, and it's not so much too different from the ones we've had before. It's just that the second one that we're multiplying doesn't have a denominator with it. But the denominator for this here would actually be 1. Because if there's not a denominator written, it's understood to be 1. So the rest of this is actually going to work the exact same as what we've been doing. So here we're still going to have x squared plus 3x plus 9 and our 1. Well, we can't actually factor x plus 2 because there's only 2 terms and there's not a greatest common factor. Now, x cubed minus 27 is a difference of perfect cubes because we would have the cubed root of x is cubed is x and the cubed root of 27 is 3. What do we think is going to go in the quadratic or the bigger set of parentheses? What do you think is going to go in here? Because if there's going to be something that simplifies, it should be this here. Now, if we check the signs, because they're going to be the same, opposite always end on a positive note. So the signs for the quadratic do match up. If we plug in the x, we would have here x. This here would be x squared and x. And we plug in the 3's, we'd have 3. Here we'd have 3 in our x, and then here we would have 3 squared. And when we simplify this here, well, here we would have x plus 2. On bottom, we would have x minus 3 times x squared plus 3x plus 9. So it actually did work out that the quadratic part of the difference of perfect cubes is the same as what we had already, yes? All right. So what we're doing now is multiplying them together, yes? I mean, the next part we've been doing is really just rewriting it with the numerators all on the same line and the denominators all on the same line, yes? I mean, I can just connect them and then go on and do our... Because all the steps when we rewrote it, we're just moving everything to be together in one fraction. So we can go on and connect them, and these two cancel, leaving us with what? X plus 2 over x minus 3. If it is helpful to rewrite it, I would rewrite it to where they're all on the same line, kind of organized, because that is sometimes helpful. Especially, are we good with this here? Because I'm about to move the slide for a second. Like this last one here, it is good to rewrite it, especially when we have these terms by themselves, to get them up in front to where we can see how they simplify. Or sometimes we can just connect them and start eliminating out the top and bottom, and it works just as well. Are there any questions on any of this here? Do we feel comfortable with these here? Yes. I have a feeling this is not going to make an impact too much at all. No.